All right, welcome back. Today we're going to take a look at a power plate capacitor and how we can actually calculate its capacitance as well as the electric field created between the two plates. It turns out that anytime you take two power plate conductors, especially like two surfaces that are generally like parallel to each other, once you connect them to a voltage source, the amount of charges, basically charges are going to mount up on each of the plates, and they're going to create an electrical field between the two plates where the electric field lines go from the positive side to the negative side. You can calculate the value of the capacitance of the capacitor by simply using the formula C equals to KD epsilon 0 multiplied by area divided by distance. Now, epsilon 0 is known as the permittivity of free space. Its unit is Coulomb square per Newton meter square, and the reason for this is because it's actually derived from, if you guys remember from electrostatics, K is equal to 1 over 4 pi times epsilon 0. So the unit of K is Newton meter square over Coulomb square. So if you reverse that, you get Coulomb square over Newton meter square. However, the other things that you need to be careful in this formula is D, which is the plate separation, the literal distance between the two plates. Usually the plate separation is given in smaller units, like millimeters or centimeters. So you have to know how to convert from, for example, millimeter square to meter square. Now we know that 1 millimeter is technically, if you want to go there using the SI system, you can just multiply by 10 to the power of -3. And since there's a power of 2, you got to raise that to the power of 2 for millimeter square to meter square. And if you want to go from centimeter square to meter square, you have to just multiply by -10 to the power of -2 to the power of 2. So 10 to the power of -2 to the power of 2. KD, on the other hand, is known as the dielectric constant, which is usually equal to 1. And if you're using the college survey book or some of the systems, usually they don't really include this in the formulas. But basically, the purpose of the dielectric constant is to increase the strength of the capacitor and basically generally increase the amount of capacitance. Now, there's a bunch of other things you need to know. Obviously, you need to know the main formula for a capacitance, which is charge per unit of voltage or charge per unit of potential difference, and that's C equals to Q over V. In some problems, they ask you to find the charge, so you have to know that Q, which is the charge, is simply C multiplied by voltage. And on the other hand, if you want to find the electric field, you can calculate the electric field simply by dividing voltage over distance. Now, over here, the electric field is measured in volts per meter, and V over here is obviously measured in volts, and D, which is the plate separation, is measured in meters. There is another variety of formulas that can be quite useful in solving questions regarding capacitors, and they are as follows. One of them is basically known as the charge density. This might be new to some of you guys, but the charge density is simply the amount of charge on each plate divided by the area. And using the charge density, sigma, you can actually find the electric field as well. It turns out the electric field can also be found using charge density. Simply divide charge density by epsilon 0. All right, let's go ahead now, take a look at this question, which is about a power plate capacitor. This is from the college survey book used for the MCAT exam. Now, what's going to happen in this question? You have to essentially find the value of the capacitance in the first part. Once you find the value of the capacitance, you have to find the charge on the positive plate and then the charge density and the magnitude of the electric field. So here's what's going to happen. In the first part, when you want to find the actual value of charge, C in part A is simply going to be, we know that's going to be epsilon 0 area over distance. KD is just 1. So we're going to plug in the numbers. Let's do that. Epsilon 0 is 8.85 times 10 to the power of -12. Area is 2 times 10 to the power of -4. It's given in the question. And the plate separation is 1 times 10 to the power of -3 meters. That's just 1 millimeter, roughly. So if you were to put that in the calculator, you are going to get 1.77 times 10 to the power of -12 farads. And we know that 10 to the power of -12 is a pico, so we can write that as 1.77 picofarad. Let's go ahead and take a look at part B now. Part B says calculate the amount of charge. Now, if you guys remember, I said from C equals to Q over V, you can rearrange that to get Q is equal to C times V. So that means charge is equal to capacitance times voltage. We found the capacitance is 1.77 times 10 to the power of negative 12 farads. And the voltage, is it given in the question? Yes, that's 3 volts. So if you multiply those, you get 5.31 times 10 to the power of negative 12 coulombs. So that's the amount of charge on the positive plate. Let's go ahead and take a look at part C now. It says, calculate the charge density on the positive plate, assuming the charge density is uniform. So density is going to be the amount of charge divided by the area. So the charge that we found is 5.31 times 10 to the power of negative 12. And the area of the plate is 2 times 10 to the power of negative 4. So that will give us a charge density of 2.66 times 10 to the power of negative 8. And the unit of charge density is just going to be coulombs per meter square. Let's move on and take a look at question D now. It says, calculate the magnitude of the electric field between the plates. So here, we're trying to find E. We know that electric field is the voltage divided by distance. Now, the electric field, which is voltage divided by distance, is going to simply be found by dividing the 3 volts of the battery over the distance between the 2 plates. So the distance between the 2 plates is 1 times 10 to the power of negative 3. Let me calculate that. That would give you a value of roughly 3,000 volts per meter. So you can just write that as 3005 volts per meter. Now, you can also find the electric field using the formula I taught you in the last part. Electric field is going to be the charge density, or sigma, divided by epsilon 0. So you can divide 2.66 times 10 to the power of negative 8 by epsilon 0, which is 8.85 times 10 to the power of negative 12. If you were to divide that, you would get a value of 3005 volts per meter. So here, as you can see, they're kind of similar to each other, and the electric field can be found using both phase. Here, just a correction. The electric field here would have to be about 3,000 accurately volts per meter. But as you can see, the numbers are very close to each other, and you can assume that you can also find the electric field using the second formula. You can obtain it for a power plate capacitor using sigma over epsilon 0. So usually this is the extent of the questions regarding like power plate capacitors. Sometimes they ask you like to find the dielectric constant, and in other times they ask you to, for example, find the area of a plate. Like they give you all the other variables, and it's just a play with algebra, the rest of the problems you might expect. So nonetheless, thank you for watching. Don't forget to subscribe. Best of luck for your exams. Bye for now.